Hello friends, in this video we are going to discuss about various scheduling algorithms and we'll make sure we solve at least 2 to 3 examples for each algorithm so that it's clear completely. Only aim of these videos are to learn the concepts in easy manner without wasting much time. Due to lockdown there are no classes which are going on, so we'll try to cover maximum topics in very less time. So let's get started. The first thing that we should be knowing here in case of scheduling is there are two types of scheduling. One is non-preemptive. Now when I say non-preemptive, it means once a process is allocated to CPU, it does not free CPU until its completion. And the second one is preemptive. Preemptive scheduling allows taking away CPU from process during execution. It ensures that the highest priority process will be executed first. So if a higher priority process and a lower priority process are into competition, always a higher priority process is given chance for execution. Now there are various criteria for performance evaluation of scheduling strategies. So here you can see the first one, I've just listed them out. The first one is CPU utilization. Now when I say CPU utilization, it is amount of time CPU remains busy. Second one is throughput, that is the number of jobs which are processed per unit time. Third is turnaround time. Here turnaround time means time elapsed between submission of a job to the CPU and completion of its execution. Fourth one is waiting time. Processes waits in ready queue to get CPU. So it's like the total sum of times spent in a ready queue by a process. And response time. Now response time here means the time from submission till the first response is produced. And finally we have fairness, that is every process should get fair share of CPU time. So these are the criteria based on which we'll be solving our problems as well. Now on the scheduling algorithms, basically in the question paper what you get are the problems. These are actually very easy problems, easy to score if you understand it well. So in the today's video we'll be covering the first algorithm, that is first come first serve. That is, we call it as Fcfs. First come first serve, the criteria that we'll be following here is the arrival time of the process. The second thing that we need to know is the mode, that is either the algorithm can be preemptive or it can be non-preemptive. So here what we are been given is non-preemptive, and if you want to implement first come first serve, then the data structure that you can use is queue, because in queue also whoever comes in first leaves first. So let's see one problem. Here what we have been given in the problem is the process number, which can be also given as process ID. The second column is the arrival time, and the third column that has been given is the burst time. Now to solve this problem, or before that we should be knowing what will be asked in the question. So this is the problem, this is the table that will be given to us, and will be asked to calculate completion time, turnaround time and the waiting time, or it could be also asked like calculate average turnaround time or average waiting time. So basically to get average turnaround time or waiting time, we need to derive all the individual values for each processes. So let's get started. The first step in solving the problem is drawing a Gantt chart, something called as Gantt chart, which I have written here. Now entire problem depends on how accurately you draw the Gantt chart. If Gantt chart goes wrong, then your entire problem goes wrong, and if Gantt chart is correct, you can get entire 10 marks or 7 marks, whatever the question is asked for. So just try to concentrate on what I'm saying. First thing that you have to focus on is what is the arrival time given. So here you can see the arrival times are 0, 1, 2, 3, 4 for each of these processes, and the burst time is the time that each process will take for its execution. Now your Gantt chart will always start with 0. So the first process that has come at 0 is P1, so I'll just write P1 over here. Now the time that P1 is taking is the burst time which is given in your problem. So your burst time given is 4. So I'll just write here at the end of P1 that it is taking 4, right? Now what you can see here is when I say 0 to 4, that means these are the time slots from 0 to 4, and now at the time interval of 4 you can see here arrival times, right? So they are starting from 0 to 4. That means at this, by the time P1 finishes its execution, all the other processes have arrived. Since this is first come first serve algorithm, what we are doing here is it has to be the process which has come first, we have to execute it first, otherwise we have to go by the based on the arrival times. Now since all of them have arrived, we'll just write the second process that has arrived, that is your P2, and the burst time taken by P2 is 3. So obviously previous process has taken 4, so 4 plus 3 will be your 7 is the total time. Next process that has arrived is P3, so I'll just write it here, that is your P3. The burst time for P3 just 1, so it will be 7 the previous plus 1, that is your 8, so that I'll be writing it here. Next one that we have here is the process number 4, that is P4, and the burst time is 2, so the previous process has taken 8 units, so 8 plus 2 it will become 10, right? And the last process that we have is your P5, so I'll just write P5 as well, and the burst time that P5 requires is 5, so it will be 10 plus 5, so it will be 15. Okay, so that is your Gantt chart, so you should be careful while drawing the Gantt chart. Now once we have the Gantt chart, we'll go for the next step. Your step 2 would be just drawing the 3 additional columns in the given question. So the first column is your completion time. So now without giving you the definitions again and confusing you, I'll directly tell you how to get this value. So completion time will be the numbers that you write here at the end of each process completions, right? So you can blindly just write these values over here. So process P1 has taken at the end, it is finished at 4, right? So your P2 has finished at 7, P3 has finished at 8, P4 has finished at 10, and P5 has finished at 15. Okay, so these are your completion times for each process. So next is your turnaround time. So whenever you have to calculate turnaround time, I have written it here, it should be completion time minus the arrival time. So that is this column minus this column. So if I do that, I just get the answers very fast. That is 4 minus 0 is 4, 7 minus 1 is 6, right? 8 minus 2 is again a 6. 10 minus 3 is 7, and 15 minus 4 is 11. That's that easy to calculate turnaround time. Next we have is the waiting time. Now waiting time is turnaround time minus the burst time, that is the column that we have calculated just now minus the burst time, that is this column. So 4 minus 4 is your 0, 6 minus 3, that is this minus this, is you are getting 3. Next is 6 minus 1, it is 5. Next is 7 minus 2, it is again of 5. And lastly we have 11 minus 5, that's 6. Isn't it very fast to calculate? So that's all what we have to do. And finally we have to just calculate the average turnaround time. This we all know how to calculate, that is just write all these values and divide, that is sum up all these values and divide it by the number of processes. So I'll just write them all, that is 4 plus 6 plus 6 plus 7 plus 11. I think I've taken all 5, yes, and then just divide it by 5, and that is what you're getting is 6.8. Next what we have to calculate is average waiting time. So average waiting time, I'll just write all these values again. So it is 0 plus 3 plus 5 plus 5 plus 6 and divided by 5 again, because we have 5 processes, and the answer that we are getting here is 3.8. That's all. So this gives you total 7 marks. I hope you all have understood how to solve this problem. So the first thing that you need to take into consideration is just draw the Gantt chart and make sure you are solving it properly. And once the Gantt chart is done, hardly it takes 2 minutes to draw the other values and give you the average turnaround time and average waiting time. We just see one more problem now. So another problem here that I have already written it down, and it is saying that it has just got 3 processes and burst times are also given. Since I said that I'll be solving at least 2 to 3 examples, different examples for each algorithm. So here what you can see the difference is there is no arrival time which has been given to you. So whenever arrival time is not given in the question, you have to assume the arrival time, and always assume the arrival time to be 0. So that means all the processes have arrived at the same time. So I'll just try. I think by now you'll be very quick in solving this. So I'll just write here arrival time 0. So since all the processes have arrived at the same time, in that case you have to consider the process number or the process ID. So when there is any confusion about when all of them arrive at the same time or their burst times are same, you have to always go by the process numbers. So I'll just go with the first process now, that is P1. The burst time required for P1 is 24. So I'll just write it directly here, 24. Which is the next process is definitely P2. It will be 24 plus 3, that is 27. Next we have is the process P3. So it will be just 27 plus 5, that is your 32. If I'm not wrong, yes, it's 32. Okay, so that's your Gantt chart, very simple. Now we'll just quickly move on to the completion time. So you can directly see here completion time for P1 is 24, then completion time for P2 is 27, completion time for P3 is your 32. Next you have your turnaround time, that's your CT minus 80. Now since there is no 80 column, that is arrival time column here, we know it's 0. So whatever is your completion time will be same as your turnaround time, or vice versa, turnaround time is same as your completion time. So it is 24, 27. I'll just copy the same thing, same values here because it's same, 32. And lastly we have the waiting time. So waiting time will be turnaround time minus the burst time. So here it is 0, then 27 minus 3 will be 24, and lastly 32 minus 5 will be 27. And here when I take the average of 24 plus 27 plus 32 divided by, this time it will be 3 because we have only 3 processes, the answer that we get is 27.6. And for average waiting time, that is 0 plus 24 plus 27 divided by 3, we are getting it to be 17. So please cross check the values as you get it. I think this is also clear. So we'll just quickly move on to the next thing that we have with us, that is your disadvantage. Now this algorithm has got a disadvantage which we call it as a convoy effect. Now when I say convoy effect, what it means is that now we are in this algorithm, we are just considering the process that has arrived first and we are giving the CPU to it. We are not even considering the time, that is burst time, that process will take. So if a larger process comes in first, then it will keep the other processes waiting even if their burst times are very less. So here I've just drawn one example and I'll just explain it. I have already solved it for you. I'll just go through it once. That is, we have 3 processes here. Just look into wherever my mouse pointer is pointing to. So we have process 1 with 0 arrival time, P2 with 1 and P3 with 1. So since at 0 only one process has arrived, the burst time is 20. So we have to place P1 into the Gantt chart. So it is 20, next is P2 which has come into, and next is P3 which has come into. So it is burst time is 2 for P2, so we have 22, and for 3 it is 1, so it is 22 plus 1, that is 23. Next we are drawing the completion time. So completion time for P1 is 20, P2 is 22, P3 is 23. Next we have is the turnaround time, which we have already seen. What is turnaround time? Is completion time minus the arrival time. So 20 minus 0 is 20, 22 minus 1 is 21, 23 minus 1 is 22. And the waiting time is your turnaround time minus the burst time. So this is 20 minus 20, which we are getting here is 0. 21 minus 2 is 19, and 22 minus 1 is 21. So now if I have to compare this effect, I just need to calculate the average waiting time. So here what I'm getting is 0 plus 19 plus 21 divided by 3. What I'm getting here is 13.33. okay. Now if I solve the same problem by little changes, that is, if I give process 1 arrival time has 1, and if P2 and P3 0 0, that means the processes with the smaller burst times arrives first and the larger ones arrives later. So in that case, if I go to solve, so here P2 comes in first in your Gantt chart. P2 requires burst time of 2. Next we have P3, so it requires burst time of 1, that is 3. And lastly we have P1, that is 20 plus 3 is 23. Next we calculate the completion time, that is for P1. Now when you are writing for P1, do not directly just take it from here, because now your P1 is at the end of your Gantt chart and not in the beginning. It's not always that P1 will be in the beginning. So your P1 is here. So what is the total completion time of this? That is 23. So it will come here. Next is your P2. So just go, where is P2? It's here, and the completion time is 2, and the completion time for P3 is 3. So that is how you will be writing the completion times. And next comes your turnaround time, that is obviously the completion time minus the arrival time, so that we have already written, and the waiting time. So can you see a huge difference in the waiting times? Here we are getting like big values, and here we are getting very less. So when I take the average of this, I'm just getting 1.33, and here it was a huge value, that was 13.33, which makes a major difference in computations. So that's the disadvantage of your first come first serve, that's called as convoy effect. So I have just another example here. It's little different, so and just we'll do that, and then I'll just give you one homework problem, and that will be done for the day. So now why have I considered this problem? Because it is again little different. Although first come first serve is very easy algorithm, but there are little, if the questions can come little tricky way, so you should be in a position to solve any kind of question. So the first one that we saw is, if arrival times are not given, then how do we solve it? And this is the second one. Now here you can see arrival times are given, but there is a gap between the arrival times. The processes are not coming continuously, or they are not coming in sequence. So I'll just write and start with the problem. So that's arrival time 0. So at arrival time 0 we have process P1 with us. So I'll just write that, because that is the only process that we have here. Okay, the burst time for P1 is 2. So obviously blindly we can just write it as 2 here. Okay, and next at time 2, do we have any processes? We don't have any processes here. So what happens from 2 to 3, that is one time slot? In this case, it's not that the processes are waiting for the CPUs, rather the CPU is waiting for the processes to arrive. So what happens is the CPU remains idle from 2 to 3, right? I hope you have understood. Since the arrival time is 0 here and 3 here, there is a gap, okay, and the burst time of process P1 is just 2, so it is just utilizing 2 time units, and there is a gap of 1 time unit between the process 2 to arrive and process 1 to finish. So from 2 to 3 the CPU is idle. So at time slot 3, your process 2 has arrived, so I'll just write process 2. The burst time for P2 is just 1, so I'll just write here it will be 3 plus 1, so it is 4, right? So we have any processes arrived here? No. So again there is a time wherein CPU is idle, that is from 4 to 5, again the CPU is idle. So we'll just write it here. From 4 to 5 the CPU is idle. 5 and at 5 arrival time process P3 has arrived, and the burst time required for P3 is 6, so it is 6 plus the previous timing, that is 5, so it will be 6 plus 5, sorry, that is it, right. So that is how it has we have to draw the Gantt chart carefully. So if this thing goes wrong, then these things will obviously go wrong and further problem. So now can you write the completion time for P1? So completion time for P1 is 2. Completion time for P2 is directly coming over here, that is 4. And completion time for P3 is 11, that is over here. So this is one of the easiest ways. You don't have to worry and you don't have to go through these values. Just by looking at your Gantt chart you can draw these values. Okay, next is you have your turnaround time. So it's obviously 2, 1, and 6. And waiting times, now in this case no process had to wait. Okay, that is what we know, but now going by the values, if you check, turnaround time minus burst time, 2 minus 2 is 0. Next is 1 minus 1 is 0, and 6 because 0, because in this problem CPU was waiting for the processes and processes didn't have to wait. So that is surety that your problem solved is correct, because waiting time that you have got here is 0. So that's all, and then you have to just calculate the averages. Average is your average turnaround time and average waiting time, so that you can take it as in homework and try to solve average turnaround time. 2 plus 1 plus 6 divided by 3, and definitely average waiting time will be 0, right? Okay, so that's all for today, and I've just given one problem for homework. You can just solve it. I've given you the answers as well, but do not see the answers first. Try to solve it and see if you're getting the correct answers, and do subscribe my channel, and if for any doubts you can comment below. Thank you so much.